Welcome everybody. So today we'll talk about how to create this running water stream from top of a stairs, some velocity and reaction to the stones, and some white water and foam, and all will be rendered in Arnold. The geometry here you see, I brought it from Megascan and I imported to Houdini. This is in reverse, this is the foam, and this is the box that I used to initiate and create the water. It's another view. So I want to show it, so it's just for demonstration. Where is the water coming from? And it's hitting the walls here. See? Falling down. In reverse also. So let's go to the scene. So here let's give it a second. A quick cell bridge, like 3D asset. Let's write stair. And you will get it like this one. Okay, here in the download setting you can define what exactly you prefer, JPEG or EXR for higher resolution. And the model, each one level 0 have everything, and level of distance or detail, level of detail, or the high poly source. The export target, you have all of this. So I choose Houdini. If the plugin is not installed, you will install it. You will define also the texture, the model that you want to export, and you can define the name. After you hit download, then you will press export. After you install the plugin, you will have the megascan. So here you have Arnold, Mantra, Redshift, Renderman, no V-Ray. So like choose Arnold, you have either triplanar or standard surface. I choose standard surface. And here if you import USD, it will create the USD for you also. So in case you want Redshift, you need to choose here Redshift. So quick cell bridge will make sure when transfer here, it will be converted to a Redshift material or Arnold. So in this example, this is the stairs. You bring the file, it will make it smaller. It will delete the FBX or any extra attribute you don't need. It will apply the material and give you an output. This is the material. It's Arnold. You have the output. You have the standard material. And connected to it the albedo or the diffuse, the roughness material, the specular roughness, and the normal map. Connect to normal map node and to the normal, and you have displacement. What I did here, I make the displacement or the normal is the same. Roughness, you can lower it, sometimes it will be very big. I brought all these material, make them ready here. So this is the geometry. They want the water to start from here and go all the way down. So I brought, give it a second. I merge import or object import all the material, and as you can see they are thin, not watertight, so I had to make some geometry or a volume, so I use extrude volume, so I have some watertight sealed geometry. I convert it to VDV, make it 0.05, then convert it back to polygon with some adaptivity, so I have less polygons. So this way I make sure that all of it is one piece and no, like here, no gaps between this and this, see? So it's intersection with this and this. No intersection, see? This is from the inside. Before it was like this. See this pulp from the other paper. Then again I make a VDB from it, or I can use that one from previous one just to make it ready for the collision. I created a box, put it here, give it some small noise and some velocity, a random velocity, mainly on the negative x, with some curve noise, and that's animated. So the water source will be different each time in its velocity for more interesting shape. I created volume rasterize attribute for the V with some rasterization. Want from volume and volume trails up just to show the velocity, as you can see here. So when the particle for the water or the flip is created, it will have this, it will inherit this velocity, so it will be chaotic to some degree, not smooth. Some will go here, some will go here, some will go all direction. So this is the preparation. Now to the flip. For the flip, I have the flip object that will define the particle separation. I didn't add any jitter or any initial velocity because already I have it. Also, I need a volume source. The volume source is the service that we use in from here. Let's go again to out surface. This one, just the box. So we have it here, which have the surface, and here also I have volume source. What's important, I make it bump. Here it's a source flip, so this is for the density. This one for the velocity, I make it as a bump. So I have the V that's converted to velocity, which is a vector. It's connected to volume velocity, so it will inherit the movement of the point velocity. We brought the stairs and we make sure in the collision volume sample we use the VDV as a proxy and we run the simulation. After we finish the simulation, we will import it, double import, and we run the fluid compression, so it will make it smaller in size on the hard disk, and we save it. So this is how it is being compressed. If we add particle fluid surface, it will show us the particle from the disk already loaded after simming. So it's loading here, as you can see, and the color according to the speed and velocity of the particle. The whiter, the faster. Then here I deleted the extra points. You can see here, and this is before delete. All these ones, because they are not being involved in the render, to decrease the amount the surface will take to be created. Let's load this one. This is after I save the surface. Let's make it a new one, and in the particle fluid surface, the same particle separation. The voxel scale I make it 0.55 and I keep the rest the same. I added some dilation and some smoothness, mean curvature flow I used, and erode of 1, so it's very sharp on the edge. As you can see, it's pointy. You see another frame. Just loading, give it a second. So as you can see, this is the box that sourcing the water I wanted to show. See, it's pointing, not like a pulp or like a bubble. After that, I didn't use any fluid interior, the white water source, and I'm taking this this null, because initially it will try to read from here, but already I did the simulation. It will read from here. So I added this null, and it's being added here, so I have some white water source, and I kept all the default. I didn't change any. Already it's chaotic enough, as you can see. Like if we view here, it somewhere. 1 second. I don't know where is it. Anyway, stop it. So after you will have your volume, it will have the emit volume. Okay, you can save it. I didn't save. Then you take this one and you go to the white water sim, which is very simple. You have the same geometry. You have a white water object. I kept it as default. In the white water solver, I enable add state attribute. So you will have your foam, your bubble, your spray. Here you can increase the amount of spray, and here you can play with the percentage or the amount of foam or spray or bubble. The higher you put it, the less the particle will stay according to the lifespan. One thing in particular, you need to make sure in the flip solver previously that the vorticity you activated, so it can you will have that attribute. So when you do the white water sourcing, you have the vorticity already, you have the attribute, so it can be calculated, otherwise it won't see it. So this is very important. After that, I run the simulation and I save it. Let's have a look. I put it in a triangle here so you can see it. So I'm running on bones, the spray taking the red, the green is the foam, as you can see, and the blue is the bubble that's beneath the water. So if you look here, this is the surface of the water, deeper below zero, bubble, zero, approximately zero is the foam, and the splashes above zero, they are the spray. And I did the same thing, and I cut off all of the unnecessary areas, because I made the size bigger a little bit for the white water. Then I ran it through the same volume rasterize, but I make it 0.025, and this is the volume that will be rendered. Here I wanted to add also extra layer of the spray, but it was already heavy enough, so I didn't add it. But what I did, I added a blast, whatever above 0.3 to keep and remove the other, so I'm having the spray. So these can be replicated and added on top of the simulation. It will look cool. So just remove it. After that, I was running Redshift. Then I wanted to try Arnold. I have HDRI. Intensity I make it higher 5, so it's not being visible to the camera, so the background will be black, so the alpha will be 0. And I make it a little bit big. Couple of camera movement. And for the material, already the geometry, we have the material. The water is a standard material. No diffuse light. Specular, I make it 1 with very tiny roughness, and this is the index of refraction for the water. Transmission, I make it 1, so it's transparent with very minimum depth. a little bit of coating for extra shining and the same index of refraction, so it's the typical, and a little bit of sheen, very tiny. That's it for the water. The white water, I use a volume with high density 3.5 wide for the scattering, and transparency I make it also depth of 1, but not very wide, no emission, you can put it none. Particle I didn't use, but same principle. I was playing with material X, I'm trying to figure it out. This is the redshift material, I just choose water, but I remove what? I remove this one, where is it? Dispersion, I just remove it when I was playing with the redshift also. In the out, I have Arnold. Property, I kept it the same, just a JPEG. Sampling, I went down to 2, and I minimized the total rays and the transmission and transparency. And device, I used the GPU, so they are running in sequence, and in the control I make it node by node, so it will finish the first node, then the second node, then the third node. In the top here I was doing the simulation one by one, rob and fetching, and this is the outcome. See it again. And Arnold was quite quick to some degree on the GPU, even I have very old GPU. See the splashes, very shiny. Thank you very much for watching, and thank you for the support also. Please like, comment and share.